Hello students, today we will start a new chapter, lines and angles. It's a geometric chapter, and the definition of basic terms are given on your book, so read it properly. Here we will first prove a theorem. It's theorem 6.1. It's in the theorem it's given that if two lines intersect each other, then the vertically opposite angles are equal. About vertically opposite angles, so given in the definition part. So read the book properly and see first, if two lines intersect each other, let us we have to draw two lines. Suppose we draw a line here and another line intersect each other at a point. Suppose first line is AB and second line is CD. Since it's a line, so you have to give arrow marks. If it is given that line segment, then no need to give this arrow mark. Now they intersect each other, suppose at some point O. Now if two lines intersect each other, these two AB and CD are two lines intersect each other at a point O. Now you have to show that then the vertically opposite angles are equal. So vertically opposite angles means this angle AOC is equal to angle BOD. That is, we have to put that these are the vertically opposite angles and we have to show that they are equal. Another pair of vertically opposite angles are there. Here this angle AOD and this vertically opposite angle is this CBOC. Vertical COB or BOC is same. So we have to show that this angle is equal to this angle, that is vertically opposite angle, and this angle is equal to this angle. Now first, since AB and CD are not given on this question, someone may draw PQ and RS or any name. So first we have to write special statement. So first we have to introduce the figure here. So let AB and CD, no need to give this symbol here. In case of line, you have to give this symbol, but it's not necessary. So we simply write AB and CD, B, two lines intersect each other at some point O. So at point O. So to prove what we have to prove here, that first one, angle AOC is equal to BOD, angle BOD, and secondly we have to prove that angle AOD is equal to angle BOC. So we have to write this part. Since AB and CD is not given in the question, so we have to identify the figure. Let AB and CD be two lines intersect each other at some point O, and now we have to prove that the vertically opposite angles AOC. To prove AOC is equal to BOD and AOD is equal to POC. Next part is proof. So we have three parts in this proof section. First, special statement. Next, two proofs. Next, proof. So how we prove it? See, by axiom 6.1 and 6.2, we get that if there is a line and if a ray stand on it, if a ray stand on a line, then the adjacent angles are supplementary. That is, sum of the angles so formed, that is this plus this, is equal to 180 degree. So we will apply this axiom to prove the theorem. Now see the proof. So in the proof section, since the ray OA is a ray, O is the endpoint. Since the ray OA stands on the line CD, therefore we have, since the line OA, that is, suppose this is the line CD and this is O, this is A. The figure is like this. Since the OA is a ray, stands on the line segment CD, therefore this angle AOC plus AOD is equal to 180 degree. We have angle AOC plus AOD. Angle AOD is equal to 180 degree by linear pair axiom. You can write by linear pair axiom. By linear pair axiom. Similarly, so if we take OD as a ray and stands on AB, is A, B and this is the O. AB is a line, OD is a ray, then AOD plus BOD is equal to 180 degree by the same axiom. So similarly, ray OD stands on the line AB. AB is a line and OD is a ray. Therefore, we can write angle AOD plus BOD is equal to 180 degree. You can write same by linear pair axiom. Now we get that sum of this angle is equal to 180 and sum of these two angles are also 180. So give this equation as number 1 and this equation as number 2. So from 1 and 2 we have, therefore from 1 and 2 we have, so if right hand sides 180 and 180 are same, 180 degree, so right hand side are same, then left hand side must also be same, that is angle AOC plus angle AOD is equal to angle AOD plus angle BOD. So from 1 and 2, right hand side is same, so left hand side is same. Now see, in this equation AOD and AOD same. on both sides. That means you can write angle AOC is equal to angle BOD. That is, we get AOC, this angle is equal to angle BOD. So one pair of vertically opposite angles are equal. Now similarly you can show that the other pair also same. Now for the other pair, no need to proceed like this, just right. Similarly you can show that. So similarly we can show that if a pair of vertical opposite angles are equal, then the other pair also equal. That is, angle AOD is equal to angle BOC. So, right, hence proved. Hence, and this proof is very important. And try to prove it yourself. Next, we will solve exercise 6.1. And before exercise, there are 3 examples in your book. So practice these examples yourself. So our question number 1 of exercise 6.1. So a figure is given, and in this figure it's given that line AB and CD intersect each other at O. There are 2 lines AB and CD, and they intersect each other at O, and AOC plus BOE, AOC, this angle, plus BOE, this angle, the sum of these 2 angles is equal to 70 degree, and given that BOD is equal to 40 degree. BOD means BOD, this angle is given, it's 40 degree. Now we have to find BOE, that is BOE, this angle we have to find. We have to find the measurement of this angle and reflex COE, that is COE, this angle COE. Reflex COE means this angle. This angle is reflex COE. So reflex angle means it's greater than 180 degree. So you have to find it. Now, right, solution. So according to question, angle AOC plus angle BOE is equal to 70 degree. Now see, AB and CD intersect each other. So AOC and BOD are 2 vertically opposite angles. That means they are equal. So we can replace this AOC by BOD. So angle BOD. So in place of AOC we can write BOD plus angle BOE is equal to 70 degree. Here we can write, since angle AOC is equal to angle BOD. Why? They are vertically opposite angle. That is vertically opposite angle. You can write VOA, that means vertically opposite angle. So now BOD is given. BOD is given. It's 40 degree plus BOE is equal to 70 degree. This implies angle BOE is equal to, so if we take this 40 degree to right hand side, it becomes 70 degree minus 40 degree. So becomes 30 degree. That is, we get angle BOE is equal to 30 degree. So we get one answer here. Now next we have to find the reflex of COE. That is this. So if we can find angle COE here, then from 360 degree, if we subtract COE, we get the reflex COE. So next, see how we find the reflex COE. So right, since AB is a line, so our AB is a line, therefore angle AOC plus angle COE plus angle BOE is equal to, that is AOC, this angle, plus COE plus BOE, this angle. You get the whole straight line, so equal to 180 degree. Now AOC plus BOE is given, it's 70 degree. So write angle AOC plus BOE plus angle COE is equal to 180 degree. So this equal to 70 degree, implies 70 degree plus angle COE is equal to 180 degree, that is angle COE is equal to 180 minus 70 degree. So equal to, we get 110 degree. Therefore reflex angle COE is equal to 360 degree minus angle COE, that is 360 minus 110 degree, so you get 250 degree. So you get the reflex COE. And so we find the COE by this method. You can follow the other method also. Or if CD is a line, suppose CD is a straight line, then COE plus BOE plus BOD is equal to 180 degree. Then we get this BOE plus BOD is equal to 70 degree. Now COE plus 70 is equal to 180. Then also you can get the value of COE. Or otherwise you can find the reflex COE directly is equal to this angle COD, this angle, plus EOD, that is 180 plus 70. Then also you get reflex COE. So you can use any method, just follow the correct rule or correct steps. Okay. Next, question number 3. See the question. Lines XY and MN intersect at O. So we have XY is a line, MN is another line, and intersect each other at O. This point is O. And POY is 90 degree. That is OP is perpendicular to the line XY. Now again given that A is to B, that is ratio of this angle A and B is equal to 2:3. Now we have to find the value of C, this angle. This is XO and this angle C. So here, if POY is equal to 90 degree, then obviously POX is also 90 degree, because XY is a line and OP is a ray, and XOP and POY are two adjacent angles on the same line. Therefore sum of these two angles equal to 180. So one is 90, so another angle is also 90 degree. Now if this A is to B is equal to 2:3, that means the sum of this A plus B is also 90, and from here we have to find the value of A and B here. And after getting B, so from MN is a line, so B plus C is also 180. So subtracting B from 180, you get the value of C. Now C. Solution. Since ray OP stands on the line XY, therefore angle XOP plus angle POY is equal to 180 by linear pair axiom. You can write by linear pair axiom. So is equal to angle XOP is equal to this 180 minus angle POY, and POY is given 90 degree. So you can write minus 90 degree. That is actually minus POY. So you get angle XOP is equal to 90 degree. So according to question, A is to B equal to 2 is to 3. So let A and B be twice x and thrice x. So the value of A suppose twice x and B suppose thrice x, because the ratio is 2 is to 3. Therefore we have twice x plus thrice x is equal to, that is, if we add A plus B, we get the angle XOP. Angle XOP. That means we get twice x plus thrice x. Half x equal to 90 degree. So what do we get? X equal to 90 by 5. 90 by 5, that is, we get x equal to 18 degree. Now if we get the value of x, we can find the value of B, because it is thrice x. C. Therefore B is equal to what? We get thrice x, it is 3 into 18 degree. So we have 54 degree. Now from figure we have, B plus C is equal to 180 degree. You got it? Since MN is a line, since MN is a line, and so B and C are two linear pair, or you can write linear pair. It is, or you can write only linear pair, because B and C are two angles subtend on both sides of the ray OX on the same line MN. So this implies B equal, we get 54 degree plus C is equal to 180. Now C is equal to 180 degree minus 54 degree. So when we subtract 54 from 180, we get 126 degree. So this is the answer. You get the value of C here. Now see question number 3. In question number 3, in this figure P, Q, R and S is a straight line. Given that PQR, angle PQR, this angle is equal to this PRQ. Now we have to prove that this angle PQS is equal to angle PRT. We have to show that these two external angles are also same. So proof from figure we have angle PQR plus this angle PQR plus PQS is equal to 180 degree. In bracket, right? Linear pair. It's called linear pair. So their sum is 180 degree. And similarly, angle PRQ is plus angle PRQ plus PRT. They are also linear pair. So is equal to 180 degree. Right? Linear pair. So give equation number 1 and equation number 2. Therefore, from 1 and 2 we have see, in equation number 1 and 2 both right hand side are equal. That means left hand side are also equal. So you can write angle PQR plus angle PQS is equal to angle PRQ plus angle PRT. So from equation number 1 and 2, both right hand side 180, 180, so left hand side is equal. But according to question, PQR and PRQ, they are equal. That means we can cancel out these two. So from this we get angle PQS is equal to angle PRT. That is PQS is equal to PRT. Hence proved. Right. So it's an easy sum but important sum. So practice it. Okay? Thank you.